Okay, right. Yeah, so this is going to be the last session for today, though. I'll make it very quick so we can go for a few pints afterwards, okay? Right, so probably this is going to be an extension for your presentation, though. Today, this part, we will talk about data and machine learning in the context of security, so in the context of defense and other things around it. Yeah, so a little bit about myself. As I said, my name is Saied. I am a security and machine learning architect at Visma. So what that really means, I do security in the context of machine learning and in the context of analysis and diagnosis through the analytical means. So that is really my job. Apart from that, I'm involved in cloud security and machine learning for the context, in the context of non-security related cases as well. So it's not just security, but other things as well, which are not security related. So that's what I do, but in terms of, I'm a father of two. I like to travel, meet new people from different backgrounds. During this time of the year, I like to cook, but summertime I like to garden. That's me. All right? The agenda really, this is what we're going to go through for today. The objectives, what is it that I'm trying to deliver out of this presentation? Obviously in the context of data and machine learning. I will go through data briefly, even though quite a lot of speakers talked about it today, but I have my own definition and understanding of data. And my focus really is to sort of deliver that understanding. And we're going to go through two simple experiments. These are not production kind of things. This is just experiment to explain about data and machine learning. If you want to learn more about the design and the implementation of those experiments, you can see me afterwards, but I'm just going to go through the demo for the time being. And how you can start machine learning in your company if you want to start custom solution, what kind of ingredients, steps, or needs that you need for such purpose. Then we're going to go through machine learning on a larger scale. I have focused on anomaly detection and abnormal behavior. This is one of the projects I was involved with, Visma. And then we wrap it up around continuous learning. Why do we need continuous learning in terms of data and machine learning? Okay? So, objectives. Why am I having this presentation? What is the purpose behind it, really? This is the main objectives rather behind this presentation is to share my experience when it comes to data and machine learning. I work with data and machine learning on daily basis, and I thought it would be interesting to share those experiences that I'm having, so that guys like you can hopefully start the same thing at your organization, at your company. And we keep talking about data, but I would like to, through experiments, show the evil and the goodness part of data, how this can be used for purpose of defense as well as attack, but not the kind of attack what Shane was talking about. We hear quite a lot about machine learning, artificial intelligence, and all that kind of things, but at the same time, we get a lot of false positives. I mean, people, I've experienced people saying, okay, this machine learning and artificial intelligence is really cool, but it's really shit when it comes to real life, which is, I understand. And should you go for custom machine learning solution at your company, or should you rely on third-party applications to do the job for you? Or should you go for both? This is the objectives, really. This is what I want to deliver as part of this presentation. Okay? Okay. Right, so let's start with data. Data really is the fundamental background for any business. Anything that we experience on a daily basis, when it comes to medical, mathematical, financial, military, this is all data. Without data, we can't really do anything. For example, if you think about your a medical doctor, without your previous data, your historical data, and your current data, the medical doctor cannot really perform a right analysis for your disease. The same thing will apply to financial sectors. Without proper data, you cannot perform proper financial decisions. So data is fundamental to everything that we do. Without data, we can't do anything, really. So this data that we have on daily basis, on minute by minute that we experience them, either they are structured or unstructured across the data farms. But they could be private, secret, or public. So data is private in a sense, it's dear to you. You don't want to share it unless if you want to. It's secret that shouldn't be shared at all, and it's public. It's public for everyone to see it and experience that data. But all of those data that we see that we experience on a daily basis are in the following formats. You have text, numbers, images, videos, and voices. This is data, really. Everything that we see in terms of text, numbers, and images are either structured across the data farms or unstructured, and they are in the form of private, secret, and public format. And basically, these are used by financial sectors, by military, by personnel, national, everything. So that is a very basic representation of what data is. All right? So what is data? Data is just information, really, that has some characteristic features that defines a specific example, scenarios, or an event, and hence is really powerful. And everything that you guys do on a daily basis in terms of two-factor authentications, encryptions, firewall, pen testing, essentially this is designed to protect data. That's why you perform all of those activities. And the reason that you want to do that, because you don't want to have your data to get into wrong hands. That's why you're doing this. Right. So data is very important, but data itself can be used for manipulation purposes or for protection purposes. And this is what I'm going to talk about when it comes to these two experiments. Okay? So experiment one, I want you to meet Espen Johansen. Some of you actually, I don't know if you have met this guy. He works for Visma. He is one of our security managers, and the objective of this experiment is, can we imitate Espen's writing behavior and style using a small portion of his data? In another word, can we build fake Espen using his data? So I asked Espen to provide me with some data that shows his characteristic features as an individual, and he provided me with emails, paragraphs, journals, and interviews. It was a relatively okay amount of data. But before I go, we use that data and we build a model that imitates, or we build fake Espen that imitates Espen behavior. But before I go ahead and demo that fake Espen, I would like to go through his background. I asked Espen to provide me with a little bit of his background. So this is what he sent me. Espen is an operational and security manager. He's a board member of Visma. He leads application security work as part of the Visma group. His background is military. He had several positions in the international security industry. So if we go through these lines, we can actually see repetitive patterns within them. As an analyst, when you look at those, you see, okay, he's an operational security manager. He leads the application security things, and he has several positions in the international security. But further, he's got a military background. So what that will tell us? This means this guy, he is very disciplined in a sense that everything around what he sent me is around security, military, and all that kind of stuff. So I expect fake model to be lean towards that kind of response when I ask fake model, what do you think about this? So we trained the model, and first time we ran the model, well, after a couple of times, we asked the model about what do you think of Visma's responsible disclosure program, and this is what fake model responded, fake Aspen responded. Our responsible disclosure program also encourages honest, decent hackers to have a go at our defense, and we reward them with swag and let them know how we fix the problems. This is actually a model that generated this text. So what we did out of this experiment, we used data for such purpose. We pre-processed that data and built a model that generates something that sounds like Aspen. Now, just 15 minutes ago, I rerun the model again. Just 1 second. And I asked something about China. And this is what the model responded. China is relatively new, blah, blah, blah. So I'm going to I did actually break it down into these smaller pieces. So China, a relatively new member of war, have to prioritize resources and make sure that we have fully understood what had happened. And now at the third line, the model is actually bluffing. And our weapons against the attacker. In this instance, the nation-state actor used specific set of attack tools in a short amount of time. Our incident response provider provides clarity. Now, remember, we use a small portion of Aspen's data to generate this. And the objective of this experiment is to show how data that you have on your daily basis can be used for the purpose of manipulation. And this is how powerful and machine learning is from that perspective. Okay? Remember, we only see one side of Aspen. We don't see the other side of Aspen. And that is what Aspen provided in terms of emails and paragraphs and all that kind of stuff. But what if I have more data about Aspen? What if I have publicly available Facebook data, tweets, LinkedIn information, basic Google search? Can I really improve fake Aspen? Of course. We're getting more attributes. We're learning more about Aspen's other side of Aspen's. His family life, what kind of hobbies Aspen into, how many kids Aspen has, all that kind of information, might be public information, we can use it to improve the fake Aspen to be more realistic Aspen. Okay, why this is dangerous? This is very dangerous. Because if we have an intelligent Aspen using the available data or other data that we might get from different places, we can produce much more realistic emails of Aspen. We can produce much more realistic tweets of Aspen. If we have images and videos of Aspen, we can actually create much more interesting fake videos and images of Aspen. And by doing this, one can actually generate an email from A to B to transfer this amount of money, and it really sounds like Aspen when you read it. So yes, that is the evil side of data, and in combination, in relation to machine learning. Now let's go. In this experiment, we're actually going to talk about the good side of machine learning and data. So the objective for this experiment is to design and implement an effective lightweight approach that detects and classifies activities towards services. That's a very, very simple objective. In other words, what we are trying to do is to identify whether these behaviors that we see are legitimate behaviors or behaviors towards doing something bad. For example, if you go to www.example.com/login, is this a bad behavior or is it just a genuine behavior? We know that Nmap, blah, 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 and all the other things are not genuine behavior, but what we are trying to do, get a huge amount of data like this and train a model, and that model can be used for the purpose of identifying behaviors like this. in this small experiment like this, we could have various agents, and the model could be in the cloud, where the job of these agents to collect these information, these behaviors, and send it to the cloud. And in the cloud, you have this model that verifies these behaviors to be genuine, a 0, for example, or attack, a 1. I have a mock version of this experiment here. You see? So in here, we've sent a JSON file of commands into the model, and the model verifies these to be genuine or not. So for example, someone is trying to use confluence.visma.com login. The model says, okay, this is a genuine activity. But anything around these behaviors, the model sees them as non-genuine activity. But it's really, now in this part, the model is actually confused because it sees this to be a genuine activity, and this is a false positive. And we can talk about that later. Right, so you might ask, okay, why do I need this if I can have signature-based solution in place? Well, we're not really taking patterns, we are taking behaviors. And we're using these behaviors to train a model to identify specific scenarios in a set of data. And this is what we're doing. We're teaching a model to do a specific thing, and that model responds to those learning process by saying, okay, from what I have learned, this set of behavior sounds like legitimate behavior versus attacks. So in this example, really, we are using data to protect data. Okay? Now, okay, so if you, we're going back to the objective of this presentation. If you want to start machine learning at your company, what is it? What kind of ingredients do you need? How should you start? And since I'm working on this on a daily basis, I'll get people coming up to me asking me, okay, I have 40 terabytes of data, surely I can do something with it. And the answer is yes, you can do a lot, but the question you have to ask yourself, for example, in the context of security, is what is it that you want to protect? You start with a question. What is it that I want to do? Are you planning to protect an API? Are you trying to protect an entire infrastructure? Or are you trying to identify specific behaviors? This is vitally important. And you know as we go along why this is important. And furthermore, really, the people around the table who decide machine learning and data, they need to have the domain expertise in that area. Otherwise, those people are going to choose irrelevant characteristic features for that problem that you want to solve. And having irrelevant characteristic features, you ultimately have wrong data. And having wrong data, you would have a totally different, you divert the direction of your problem to somewhere else completely. So, how do you start with this? You need appropriate and relevant data. Once you know what you are going to do, and this data needs to be pre-processed, organized, and you feed these data into a set of learning algorithms, where learning will take place. And in here, we have 3 approaches where Shane talked about as well: supervised, unsupervised, and reinforcement. So I'm not going to go through them. Basically, I could go through a simplest explanation for supervised learning. In a hypothetical way, what we are saying in supervised learning is, I have these set of scenarios, examples, and situations. If you come across these scenarios, take these kind of actions. This is a supervised learning. This is the expectations out of these scenarios and events. But when it comes to unsupervised learning, in a hypothetical way, what you could see, this is the data, I don't really know much about it, can you make sense of it for me? And this is where the model tries to group them together, cluster them together, or separately, or try to create associations between them. And the reinforcement is give and take kind of scenario. If you do well, you'll be rewarded for the action that you take. So this is what you do in a simplest way. And then once you're done with that is the output and the analysis. And this is where we apply a lot of statistics to verify what we have done, to see whether the model is not bluffing, the model hasn't memorized all of those possibilities as opposed to understanding them, whether the model is overfitted, well, we talked about that, if the model is leaning towards a specific kind of class as opposed to all the classes. And if you don't do these kind of things, you probably end up like these guys. So in England, they use artificial intelligence in the police sector. And what it says here, police officers rise concerned about biased AI. In America, there was a similar problem like this. AI is sending people to jail and getting it wrong. And this is the other side of machine learning. And the reason that you get all of these false positives, it's not because of the algorithm. It's because you've chosen wrong data, irrelevant data. The data, and that goes back to this chain again. Who should be around the table to decide what kind of characteristic features you choose for this problem, which ultimately identifies the right and relevant data for your problem? Okay? And wrong data, for example, in this situation, I could see this is an imbalanced data. The data was biased towards a certain behavior. I mean, let's think about fake Espen. We only knew one side of Espen, and him being a military guy, him being really into security and all that kind of stuff. We didn't know the other side of Espen, whether he's a family man, what kind of hobbies he has, and all that kind of stuff. So the model was really leaned towards what fake Espen, what Espen was really interested in context to the data that he provided us. Right? Okay, so this is now whatever we talked about was data in relation to machine learning. Now let's talk about anomaly detection, which is the defense part of what Shane was talking about. In this use case, we did this project a couple of years back, and the requirements back then was to identify suspicious behavior or activities towards and many endpoints. So in other words, we want to identify abnormalities without changing too much infrastructure where we were deploying this project to. Before I talk about the actual project, I would like to give you a bit of a high-level overview of the infrastructure. So this is a very dynamic environment where it's an integration environment. So we do a lot of integrations on weekly basis towards these endpoints. And the traffic towards those endpoints, it can go up to 100 million calls per second. And those behaviors were changing very, very dynamically. So the traffic comes in, you have a set of gateways with rules and regulations in place that you have to pass them to actually get in. And what we wanted to do is to identify suspicious behavior. We're not looking for patterns, we're looking for behavior towards those endpoints. And this is where things got really complicated, because we needed to understand what we mean by behavior. And when we sat down and went through the definition of abnormal behavior and the context of that project, this is what we learned. Bad behavior versus behavior with no intention. And bad behavior really speaks for itself, that the intention is to hack and attack. You try different approaches and mechanisms to identify weaknesses within the infrastructure, within the system. So that was a definition of bad behavior. But then we have another side of bad behavior, which is the behavior with no intention, really. So, for example, in the context of that project, we do a lot of integrations between different endpoints. And when you do integration, the integrations might be really bad. I mean, the programmers didn't do it very well. So that creates a lot of noise, ups and downs in terms of the pattern, depends on the behavior in that network. Or due to the lack of design, wrongly used system by users, all that kind of thing, that people actually doing something but they don't really mean it. It just happened because they don't know much about it, or the US design behind is really bad, or the integration is really bad. So that will lead to bad behavior, but with no intention. So what we did, okay, we understood all of those. We identified all the characteristic features that define behavior in general in the context of these two elements. And we tested it in both in acceptance and stage environment. Everything went cool and nice. But at the moment we deployed it on production, it was like a cluster. Yeah. I mean, things were going really bad. And so we had to roll back and understand, was it really the data? Was it the characteristic features? Or was it what went wrong? And we learned that since that environment was a very dynamic environment, in a sense that we have a lot of integrations, behaviors towards those endpoints were changing very rapidly on a weekly basis. And this is where we had to do continuous learning. So the model had to learn every week about these new behaviors and compare them to the existing ones, and anything that is not relevant, drop them. And that wasn't really easy at the beginning when we did it, because we had to find out how we can do that. But it wasn't just that. I mean, we did that. That was OK. We did this weekly training, which was automatically. And then the other thing we had to really learn about this is to provide feedback back to the model. OK, this is good, this is bad. And the model was learning from our feedback as well. So this is so that was the challenges that we faced. And we had to play around with the characteristic features that we chose as well to further improve that. This is the look and feel of the product that we work. So we get weekly, daily outputs. And we identify, in this particular one, we have 2 anomalies. 1 anomaly, 5 anomalies, 4, and all the way down. In here, this is where we provide feedback back to the model and say, OK, whatever you have found in this is really relevant to these problems, or yes, they're not relevant. So these feedback will enrich the model based on the new characteristic features and what we provide. But the decisions were made. I mean, if you click, I don't have a slide of that, but when you click in any of those reports, you get an intense detail of why the model has decided that decision, and all based on mathematics and statistics, really. From where to where. So this continuous learning that we used, from data to pre-processing, training, evaluation, and deploying it to production, this is all automated. But here, when it comes to the analysis, where we provide feedback to the model, this is where we do the review in this section. And here, yes, this report has been reviewed, but this one is not reviewed. And over time, the model is learning all of these behaviors, new behaviors, and response from us as well. OK, so remember, whenever we talk about machine learning and data analytics and all that, you should not replace your existing signature intrusion detections or anything that you have with these solutions. This is just an extra tool to help you identify the problems. This isn't a replacement mechanism. This is just an extra add-on service. So I get this question quite a lot. Should I replace everything I have with AI and machine learning? No, that's a big mistake. Don't do that. This is just an extra service. Right, let us, we are nearly done. Let's go back to the the objectives. All in all, in this presentation, I wanted to show the evil side and the good side of data in machine learning. And to learn more about data. Data is extremely important. That can change the course of a problem to a different direction completely if you're not very careful. And when it comes to, okay, should I start implementing my custom solution at my company? I think you should. It's vitally important to learn about the characteristic features that are happening at your network, things that's happening, because the more you learn about these things, the better your integrations are. You would have a better overview of things that are happening there, and it's just an extra tool to help you out. But I get another question as well. Okay, should I rely on third-party application instead of custom solutions? I would say both. You should have both. You shouldn't just rely on a third party. I think you should have your own department doing this shit. And if you want to, this is how you start. You have to have a clear idea of what you want to achieve. Make sure you have the right and applicable people for this problem. Otherwise, you get crappy data, and you might end up somewhere else completely. And spend time to learn about data, understand the scenarios, all the events. Make a proper pre-processing in place. Sometimes that will help you to have a better model. Evaluate and test it. Make a proper analysis. Don't just leave it in production. Spend endless hours to learn about all of those responses that you get. And yeah, create pipelines, build the entire infrastructure in place. Okay, so yeah, I'm done on my own time. Okay, thanks. Questions?
Thank you very much, Alan.
Yeah.
That was interesting. Are there any questions? Oh, yeah, of course.
Yeah.
So
Should be working out.
excellent work there. So I'm wondering, as a fellow, practitioner, what do you think? And it doesn't have to be specifically a machine learning innovation. What new technology do you think is going to help in your work the most that we don't have yet? Like, what do we need more of that we don't have? Because obviously, you've done a great job outlining the challenges, and you're well familiar with them. So,
In terms of applications or approaches?
yeah, or just anything. For example, let me frame the question a bit better. I think a lot of the privacy enhancement technology emerging is what I'm sifting through, because I feel like that's going to enable me to share data amongst other data scientists that may not be in the same circles of trust as, say, our incident response team or our vulnerability management team. So that's an area I'm looking at. And I'm just curious, what do you think is going to help you in your job? What are you excited about in terms of,
The most important thing for me is to actually to go through the data and identify behaviors that is, as humans, when you go through a set of data, you find certain patterns, you find certain behavior, okay? And when I build a model, and when I see that model imitating that behavior without me being involved with that, that makes me really satisfied. That's a really an interesting output for me. But at the same time, that could be a scary situation, because what I'm really worried about at the moment is not what we're doing in terms of machine learning, data. What is the end game after this? Where we are heading to in terms of data? Because data is like piling up, and we have the approaches and methodologies in place that are helping us to go further and further. But what is the end game? Where we are, I mean, I'm worried when we have quantum computing, machine learning, and all the other things are merged together. What kind of model will we get? And it's in the experimental phase right now. And that is very exciting, but it's very worrying at the same time.
Okay, thank you. Sure. Yeah, quantum. Good, that very much, that's also on the radar.
Yeah.
Any other questions? Yeah, go one in the back.
Which way?
I'll be the quarterback. No, I think I'm going to run. Okay. Afternoon exercise. Oh, you first? Okay, I saw the hands. So just pass it further back afterwards.
Yeah, sure. Okay, 2 quick questions. You mentioned AI and also in some of your slides. So what's actually the difference between AI and ML? And also, how far in the future is it going to come back and kill us?
So what is the difference between AI and ML?
Yeah.
Can't you Google that? Yeah, I'll be very quick. AI is artificial intelligence. ML is machine learning. No, I'm joking. Yeah, so AI basically covers pretty much everything, from robotics to machine learning to agents and all that kind of things around it. Machine learning, the way I see it, is the backbone of all of those technologies. For example, if you take robotics, you can do programming if you think about having a vacuum cleaner in this room, okay? The vacuum cleaner, you can program it to clean up the entire room for you without any problem. But you programmed it to be like that. But when you take that vacuum cleaner to another room, then because you have programmed it based on the context of this room, the vacuum cleaner will get confused in the other room. While if you have machine learning is, we provide data for the robot or for the vacuum cleaner to understand and learn the characteristic features of this room, including me and you. So that one makes, so yes, machine learning is a branch of artificial intelligence, but it could be the backbone of artificial intelligence. Is that?
Yeah, cool. And when is it gonna kill us? How far in the future is doomsday?
We can have a few pints, then I'll answer that question. Yeah.
The sad thing is AI is just going to have to get in line
Yeah.
to kill us.
That's good.
Any more questions?
Yeah, there was one more at the back there. No,
I think
she is.
backed out. There's one down
Yeah,
there.
there is a.
Oh, there's a question.
Hey.
More.
Yeah, so you were showing some anomaly detection and using that for some reinforced learning for that, where you had a
Well,
human
it's
in the
a
loop to
combination of algorithms at the bottom with unsupervised and supervised learning.
Yeah.
But we didn't actually use reinforcement there.
Right.
But the feedback was used as a training data set back to the model.
Yeah, right.
Yeah.
Yeah, so then still my question is valid. And as for how would you prevent loss of anomaly detection based on the model progressing? So, like previous versions of the model or previous parameter sets for the model would give you anomalies, but now they are normalized.
Yeah, that's
more
why
as an attack, because I'm on the
we're doing
red
this
side of things.
weekly because in respect to that environment, the dynamics are changing very fast. So we don't really rely on the same model for next week. We actually retrain everything back, and we use that and we cross-match them together to see whether we are having similar behaviors in both. Otherwise, we drop them. And this is all automation process that we have it in place.
Yes. Okay. So you keep an old reference and you compare.
Oh yeah,
it,
we do,
or
but we're not actually using it.
Not in the no, but you would be using it for something, for some learning. So
Well, that will be incremental
yes,
training.
as
yes,
an
for that.
incremental
Yeah,
training,
yeah,
yes, of
for
course.
that purpose,
But
yes, yes.
would you then, if you discover that this new version of the model does not detect something that it should, would you then just discard that new version of the model, or would you punish it and in some way?
I would say I'll punish it. Yeah. You would. Yeah. You would have to punish it. Yes.
That was a Jerry Clarkson moment right there. Any more questions before we give him his chocolate or honey? Honey pot, yeah, no. Actually, before you get this delicious honey, I actually want to try to answer one of the questions without any knowledge, but I'm just repeating something people in our AI team at PwC says. If it's written in Python, it's probably machine learning. If you find it in a PowerPoint, it's probably AI. Thank you very much.
Thank God I'm not doing AI. Thank you. Thanks.